Hi, this is Sam Michel again. Sam Michel. And the title of this essay is Quantum versus Galactic Plus. Not that different. Dated October 22nd. We've got a table. Table of properties, essentially, that we've listed out. And on the left is properties and states of quantum matter. And on the right, Galactic Plus scale, properties and types of matter at that scale, and more than that. And energy translation, meaning how do we transfer energy between entities. Remember, on the left is our quantum scales like nuclear, atomic, and molecular. And on the right is Galactic Plus scales, anything the size of galaxies and larger. So on the left, they're obviously from from experience, from investigation, from scientific investigation, discrete or quantized. On the right, by observation, yet again, continuous and non-quantized observationally. On the left, potentially multi-state entities, multi-state particles and particle systems. On the right, single state. On the left, according to standard model understanding, leptons and hadrons, categorized. On the right, pretty much hadronic, including dark matter. Energy translation on the left, photonic. In other words, like the photoelectric effect. That's a good example that Einstein got awarded the Nobel Prize in Physics about. On the right is GW. Of course, there's energy transfer, mass transfer, like an exploding exploding star at the end, a nova or supernova or kilonova. There's mass transfer, but we're talking about translation of energy via the fabric of space-time, which is a GW, gravitational wave. So there's differences. There's observational differences. There's on the left at quantum scales, again, that's nuclear, atomic, and molecular. It's discrete, quantized, potentially multi-state, including leptons and hadrons, and a photonic energy translation. So like when a multi-state nuclei transitions, it typically releases a gamma, which is photonic. All right, so the thing is, while there is a master force, in quotes, on the right, GR, general relativity, there is none on the left. Largely on the left, it's a balance between strong and weak nuclear forces. Although human scientists have yet to realize it, there is no difference between space-time on either side of the table, at either scale. This fundamental misunderstanding engenders or encourages human scientists to believe that different principles dominate either realm, but in reality, there are none. There's no difference. There's no different principles. It's just at the quantum scale, things are discrete as we outlined already. There are differences at those scales, different characteristics of matter at those scales. But that doesn't mean that, different laws operate on either scale. Just because we have not detected dark matter at quantum scales doesn't mean it has no influence or bearing at those scales. Similarly, we cannot assume GR is not influential there as well. Just as scientists insist quantization and discrete processes apply to galactic plus scales, I insist that both dark matter and GR apply the other way, at quantum scales. Again, there is no difference between space-time at quantum scales versus space-time at galactic plus scales. Both GR and dark matter influence things at quantum scales. We have to assume that. We have to assume that they do. A holistic perspective is easily within reach if only human scientists would realize these things.